friends, in this video we will look at the logistic regression, which is the popular method for classification, and it is also known as the binary classification method, in which there are two classes of data and we want to classify it as a 0 or a 1. However, we can also use it for multiple classes, but for multiple classes SVM is a more successful method, and logistic regression is known as the binary regression method, which classifies into two outcomes, 0 and 1. So as we can look at the definition, it can predict binary outcome 0 and 1, and it uses the sigmoid function to map the outputs. The sigmoid function, as you can look here, is an exponential function which is given as 1 upon 1 plus e raised to the power of minus z, and this function is used for the calculation of the points that we have as input. The decision boundary as we can see here, we have the function available with us, and the theta here represents the parameters, and we pass x to the function, and whatever value it is going to return, if the value is less than 0.5, it will predict a 0, otherwise it will predict a 1, and here it will be using that exponential function. And how we are getting this particular value is using the linear equation of beta 0 plus beta 1 into x. So like that it will be calculating, and beta 0 and beta 1 are the weights for the given function. So what are the applications of logistic regression? It can be used for spam classification, disease diagnosis, credit risk assessment, and customer churn prediction. Logistic regression is a powerful yet simple classification algorithm, and it has a strong mathematical foundation. Now let us look at the Python code for performing logistic regression. So as you can see here, this is a Google Colab notebook, and in this I have imported pandas as PD, and then sklearn datasets which are already available in Python along with the sklearn package. From that we are loading the iris dataset function, and then in the iris data object we are loading the load iris function, and then when we print, we can see here the values of the dataset are printed. These are 4 numerical values in the data. Each one of them represents the sepal length and petal length, and the sepal width and the petal width. Basically in this dataset we have the dataset of 3 flowers, and we want to categorize on the basis of the sepal and the petal lengths whether it is a virginica or it is a setosa or a third kind of a flower. So 3 types of flowers are there. So we can see here in the labels also, as later on also I am going to show that which kind of flower it is. So this is the data that we are printing, and these are the target variables, zeros and ones and twos, where one of them, the setosa, versicolor and virginica, these are the 3 type of flowers that we have in the data set. So this whole data set is getting printed. After that what we are doing is we are printing the feature names and the target names. So as we can see, the feature names are sepal length, sepal width, then petal length, petal width, and as we can see here, the target names are setosa, versicolor and virginica. So first of all, we are copying this into the data frame. So we are constructing a data frame using the iris data, and we are setting the column names as the feature names, and then we are setting the target also in this data frame. After that what we are doing is we are doing a mapping of the various target variable. So 0 is for setosa, 1 is for versicolor and 2 is for virginica, using the map function in Python, and then we are just printing the target so that we know that what is being stored in our data set. After that what we are doing is we are dropping the target from the we are constructing the x and the y for training our particular logistic regression model. So x and y's are getting constructed. After that we are splitting the data into testing and training For this we are using the sklearn linear model, logistic regression, and train and test split functions. So we are divided the data into the training and the testing data using the test and train function. Then we are creating an object of logistic regression and calling the fit function on it using the training data. So after the training, we predict for the testing data, and you can see here Y prediction is getting generated for the predicted data. After that, we are comparing the testing and the predicted data, and the accuracy is getting calculated. For this sklearn matrix, accuracy score function is being used here, and then the confusion matrix is constructed whether it is correctly identifying the function particular flower or not. So this is how you can perform the logistic regression using Python. I hope this video is useful to you. Thank you very much for watching.